Okay, today we're demonstrating Charles' law, which is V1 over T1 is equal to V2 over T2. They're directly proportional, so we're going to put this balloon outside, and since the sun will heat it up, then it should expand because the molecules will move around faster and take up more volume. And then we're taking this balloon and putting it in the freezer, and since it's going to be colder, the molecules will slow down and it will take up less volume. And then we're going to measure their circumference of each and determine if it's true or not. Tell me when this goes.
So I'm going to write this down.
Okay, so, yeah, you can write this down. Okay, so we're measuring the circumference of the balloon that's going to go into the freezer. And it is about 77 centimeters in circumference. And then we're going to do the same thing to the one that's going to go outside.
You're measuring inches, isn't it?
And it is 80 centimeters. Alright, so back to Charles' law, and we left each balloon, and this one is from the freezer where it was 77 centimeters before. We left it in the freezer at 0 degrees Fahrenheit for 30 minutes, and now we're remeasuring it. And it is 76 centimeters in diameter, circumference. Alright. Alright, so we took this balloon from outside after it was outside for 30 minutes, and it was 89 degrees Fahrenheit, and it was 80 centimeters before, so it should have expanded, and now it is 81 centimeters in circumference.
Okay, so here we have set up Charles' law equations, and so this is our equation that we've set up, and we have a balloon 6 liters in 294 K, and if we raise the temperature to 305 K, we need to find the volume. So first we're going to divide the first volume by the temperature, and then set it equal to V2 over 305 K. So that is 0.02 equals V divided by 305 K. And now I need to get rid of 305 K, so we're going to multiply 305 K by both sides. And our new volume is 6.22 liters.
Okay, go.
Okay, now we're going to demonstrate Boyle's law, which is PV equals PV, which is inversely proportional. So we're going to demonstrate this with a syringe and a marshmallow. So as you see here, the marshmallow is about 2 milliliters, and as you pull the syringe out, the volume should increase as the pressure goes down. Okay. Yes, and it goes to 3 milliliters. And then as we go back, it goes back. Yep.
Yes.
Now go.
Okay, so we have set up our Boyle's law equations, and the equation is P1 times V1 equals P2 times V2. Now our experiment was a marshmallow in a syringe and expanding and contracting it. Here we have set up our information. We have our first pressure and our first volume, 1 atm and 2 milliliters. We're going to find out our final pressure, and then we have our final volume. Now we have to do the conversions from milliliters. So we have 2 milliliters, and we convert that to 0.002 liters, 3 milliliters into 0.003 liters. Then we have our PV equals PV equation set up here. Now what we need to do is we need to multiply these two together, the pressure and the volume, which is just going to equal 0.002 liters. And then that's going to equal our second pressure times our second volume, 0.003 milliliters. Or liters. That should be liters.
Oops.
And that should be liters. Okay, now we're going to divide both sides by 0.003 liters. And that gives us 0.66 equals our final pressure.
Okay, so we're going to demonstrate the Gay-Lussac law, which is P1 over T1 equals P2 over T2 by putting this egg on top of a jar with the match inside, and the temperature will increase whenever we put the egg on top, causing the pressure to also increase, and then when the match goes out, the temperature will decrease and so will the pressure, causing the egg to go into the bottle and to make the pressure equalize.
Yay!
Okay. Okay, so here's our information for Gay-Lussac's law. Here's our equation, which is P1 divided by T1 equals P2 divided by T2, and this goes with the egg in the bottle experiment. Here's our information. Our first pressure, our starting pressure, is 7 atmospheres, and our starting temperature of the flame is 873 K. We're going to try and solve for our second pressure, and our second temperature is 531 K. Now here's our equation we have set up. First thing we want to do is divide 7 atm by 873 K. That is 0.008. And set that equal to P2 over 531 K. And now we're going to want to multiply both sides by 531. And that gives us 4.25 equals our final pressure. It has to be lit.
Drop it in.
It went out. Okay, it already went out.
We'll see.
It's not gonna work. We need 2 at once.
Just put the match in there. This is too smoky. This is making me really nervous. Oh my gosh, let the smoke detectors go off. Don't do that!
How do I stop it?
That's it. Don't.